pleasant day to everyone. I am Krizler from the Philippines. But before I start, I want to thank first Natalie and Thomas and the entire team of the BES Macroecology SIG for organizing this fantastic conference and gathering. So it is really a pleasure to be here and share some insights and ideas to advancing the protection of our environment and our planet. So in my today's plenary talk, I will focus more on the global conservation priorities of bats in caves and subterranean biomes. So they are key ecological species but are often neglected and overlooked despite of their significant contributions to our ecosystems and the human welfare. I really do hope that you will find this plenary interesting and will inspire you to do more research and collaboration to advance further bat cave conservation globally. So I think everyone is familiar that we're currently facing different and extreme ecological changes. Our home planet Earth is being forced to change significantly, which is mainly driven by various human needs and activities. So as we enter the sixth mass extinction with accelerating rate higher than the previously projected, the identification of species and ecosystems that are at higher risk is the core of applied conservation biology. However, achieving effective and long-term conservation is often challenged by many factors, such as the limited resources and funding allocation, as well as the capacity to implement conservation actions on ground. Thus, it is really important to develop priorities to identify systems and population that requires the immediate interventions and protection. However, not all species and ecosystems are perceived equally. One example of these are bats. So many bat species are threatened by various threats, and the human impacts coupled with a changing environment are among the key drivers for many species declines around the world. Yet, as conservation decision is often based on species perceived as charismatic, such as those megafauna, that is sometimes not the best representative to entirely protect a community or a large fraction of species. This strategy is actually leaving behind many important and critical habitats, including a large fraction of bats and their habitat around the world. For this plenary, I will focus on the conservation of cave-dwelling bats and their potential as a surrogate to protect subterranean habitats. So we all know that modern technologies are now applied to understand environmental processes and measure threats on the above-ground surface, such as forests, which can easily be mapped with remote sensing technologies. Yet, most subterranean habitats, including caves, are challenging to map and have frequently been overlooked and neglected in many prioritization. Among Earth's ecosystem, caves and underground ecosystems covers around 20% of land surface, but they're often underrated despite it contains many unique and endemic species. For example, in Chinese and many other tropical Southeast Asian caves, there is an estimated of at least 90% of the described species are new to science. However, many cave ecosystems continue to lack systematic studies and conservation in many regions. For example, in this region alone, there are over 800,000 square kilometers of karst areas and many species remains undiscovered. But only 13% of these total karst and cave ecosystems are protected by international or statutory policies. So indeed, there are clear gaps in conservation of these fragile ecosystems, and there's a need to develop effective measures so that we can conserve and protect remaining intact or highly threatened caves. But again, developing such measures is a bit challenging, and therefore there's a need to establish holistic and cost-effective strategies. So surrogate taxa are often used as a shortcut or a cost-effective approach to identify geographical or species that needs immediate protection. Within cave ecosystems, bats are ideal taxa as they provide various ecosystem services. This includes pollination, seed dispersal, and insect pest reduction. And in return, when they go back inside caves, bats are considered as a keystone species as they provide energy from the outside in the form of their excreta. This is really important for many cave-dependent species such as macroinvertebrates. Therefore, bats can be considered important cave conservation surrogates. So in other words, conserving bats means we are also conserving potentially more species within the caves. So that so that we can fully understand the extent and the diversity of cave-dwelling bats, we map first their distribution and conservation status using the IUCN data. We found that among biogeographical realm, the Indo-Malayan region have the highest estimated species richness of cave-dwelling bats, which is congruent to the global patterns of mammalian diversity and richness. We also found that the highest endemism proportion is observed in the Australoceanian, spanning across the Old World tropics, while in country level, China and Indonesia are the most species rich in terms of estimated number of species. Moreover, we also found that 25% of the cave bats are in threatened categories, and 12% are actually data deficient, which is a bit higher or significantly higher compared to other groups. We estimated the proportion of cave bat species threatened with extinction, and we found that 13% to 25% of all the species, with 15% global average, it's the rate of the extinction risk of all cave-dwelling bats, which is lower compared to all global species of bats at 16 to 35%. We found that narrowed species range is an important factor linked to higher species extinction. So this is common to, I guess, at least in mammal extinction risk. For example, island endemic species have higher extinction risks compared to those in the mainland. And same patterns with those geopolitically endemic species, or those species that can be found in a single country only, versus to those species that are widespread or distributed in multiple countries. So we have a very high bat species diversity globally. Yet, in our analysis, it is revealed that many species are still facing multiple threats from direct, indirect, and natural threats. So we found that nearly 3/4 of the cave-dwelling bat species are exposed to various threats, according to our first analysis. We found that the proportion of direct and indirect threats differed regionally. For example, hunting is more common in the Indo-Malayan and Afrotropics compared to other regions, while natural threats such as changing climate and increased storm remain a lack of clear understanding of their threats to species. So this is something that still requires more investigation and research. So I will discuss some key threats of cave-dwelling bats. I will not discuss all the threats. I will just choose those that are key and important. So hunting is one of the obvious threats to many species, and this is threatening at least 18% for the entire global species. However, hunting as a threat is sometimes underestimated for bats, especially cave-dwelling bats. For example, in our previous analysis, it only showed that around 20% of the bats are threatened by hunting. So this is in contrary to what we found in our recent analysis, showing that 29% of the species occurring from the old world tropics alone are hunted, and 44% of these are in the non-threatened categories. So subsistence is the primary reason for hunting bats, but this can also be attributed to the lack of state policies that reinforce the protection of species. And not only the species, but also the caves from being hunted or harvested in massive amount. So especially those that are not classified threatened. Such case may lead to this term that we coined, what we called as the passenger pigeon fiasco effects, or where common and abundant species occurring in caves may become extinct as a result of continuous human activities such as hunting and food consumption, especially given that many species lack overarching legislative measures for protection. However, this is not yet known for a larger scales, and we're still working on this aspect of bat conservation. Next threat are from the surface. So mining for mineral and cement are one of the key direct threats for many species and fragile karst habitats. So as the global infrastructure is increasing in many regions, the demand for cement is also increasing. We found that almost half of total cement production is from the karst areas of tropical Asia. So interestingly, cement export and production is significantly higher and congruent in countries with high cave bat species richness, as well as the proportion of endemic and threatened species. For example, in the southern China, Thailand, and Indonesia. So lastly, surface land use changes may indirectly threaten species, but it may be an important factor that increases the risk of species and habitats from future loss. For example, cave sites in more areas where deforestation is high will likely to lose more foraging grounds for bats, and more open area are more susceptible for human intrusion because they're highly visible to hunting and accessible for tourism use. So in our global analysis, we try to measure the vulnerability of caves in key surface threats. But before doing that, we need to develop a tool. So prioritizing caves is indeed challenging. Like we mentioned earlier, it's difficult to map, it's difficult to remotely sense. So we developed a tool to address these challenges. We developed the Bat Cave Vulnerability Index, or what we call as the BCVI. So this is a holistic tool that encompasses both species diversity, landscape features, and threats to assess habitat vulnerability in community and local levels. This is an adaptive management tool that weighs the relative priorities of caves and can be used to complement selection of caves for conservation and use. Actually, there's a fun fact about our development of BCVI. So the BCVI is actually my undergraduate project that was rejected 12 years ago. So this never succeeded as my undergraduate thesis and has later become the foundation of my entire PhD project. So BCVI was developed to address important gaps in cave and bat conservation in holistic and encompassing way. So this is useful to determining and to know how to protect intact cave ecosystem that contains high biodiversity of bat communities. However, the information needed to evaluate such priorities in a global scale using the BCVI remains unstandardized, consolidated, and a little information is available for the cave-dwelling bats and cave ecosystems. So to do that, first we need to construct a database for cave-dwelling bats, including their distribution, traits, landscape features, and other biological information. Thus, we developed a collaborative project which we called as the Dark Side S1. It's a global database for bats in cars and caves. This is a collaborative and an open access database aiming at collating and synthesizing publicly available data set of cave-dwelling bats. So using this data set and with the integration with the BCVI framework, we advance our prioritization scheme in regional and global scale. So currently, the Dark Side S project, which I really thank the entire team. I cannot mention everyone, but they are very instrumental, and I really appreciate this collaboration, which involves at least 30 plus collaborators from across the world, and the database contains 7,000 plus occurrences data for 402 species, representing at least the 59% of all cave-dwelling species. This is coming from 2,002 cave sites around the world. So the database is designed to be collaborative, open access, and a user-friendly platform so that it allows continuous data sharing among community of bat researchers and conservation biologists. So we modified the BCVI, the first BCVI, to fit in with the global context of the analysis. So using the new global bat cave vulnerability index and the collated data from the Dark Side S database, we constructed broad and fine-scale priorities using bat diversity data and landscape features. So using a high-resolution landscape data, we mapped 12 landscape and human variables. So globally, we found that 7 out of 12 landscape variables showed a significant relationship to species diversity, but none of these variables really showed a strong correlation to cave biotic values. Furthermore, using socio-ecological variables such as the GDP per capita and percent forest cover and cement production as a proxy to assess the vulnerability of geopolitical species, it is consistently showing a positive correlation among species ecological status such as richness, endemism, and conservation status. Then go back to the landscape features. So among the 12 variables, we used only 6 variables to assess susceptibility of caves to integrate in BCVI analysis. So at first, we found that the rate of evolutionary distinctiveness and weighted endemism differed regionally, and this is more related to latitude. Regionally, cave sites from the Neotropical region has the highest mean rate of evolutionary distinctiveness, and this is in contrast to the Palearctic region, while the cave-weighted endemism is highest in the Australoceania. This is consistent with the proportion of species endemism observed in the region. So according to our analysis, the overall pattern showed that most caves with lower threat levels showed higher cave biotic potential, example evolutionary distinctiveness and endemism, though this may be due to the previous loss of species from more disturbed caves, and this pattern is only significant in fine scale level analysis or the analysis of priorities in a site level. So furthermore, using the BCVI indices, in a broad scale, we showed an even distribution of priorities with 95% of the caves show high biotic vulnerability, which falls on the status A, but only 1% with high biotic potential values in level 1. On the other hand, fine-scale BCVA analyses showed more even distribution of priorities compared to the broad scale. So even though 41% of the caves are still at a lower biotic potential, there is an increase of 19% of high biotic potential caves. Moreover, a high proportion of high vulnerability caves are located mostly in the tropical realms. So the BCVI was then translated to set priorities. So we have 4 priority levels. So we have the red, green, yellow, and blue priority caves. So we estimated that 3 to 28% of the bat caves are in the red priority globally that needs immediate conservation interventions or protection, while 9 to 35% require monitoring due to high diversity but low risk at present. So among regions, the highest concentration of conservation priority needs are in the Palearctic and the tropical regions, except the Afrotropic, which still requires more intensive data. Moreover, our present work offers a first baseline evidence of priorities of hard-to-map biodiversity hotspots, such as caves and subterranean ecosystems. While there's no single silver bullet to resolve all the challenges that we presented on this work, this current project or this current analysis will serve as a foundation of greater work in the future. We have identified challenges and gaps that sought to be addressed in the future, which were not explored in the current work. For example, we only accounted for the 59% of the global cave-dwelling species, and the species coverage continue to widely varies by region. For example, Indonesia has some of the highest estimated bat cave species richness, yet its contribution to the data set based on surveys and assessment is among the lowest. Furthermore, accurate and systematic taxonomic studies for bats are really vital to appropriate conservation, as caves host high endemism and many cave bats have high numbers of as yet undescribed cryptic species. So, in summary, caves and underground habitats are important for nearly half of global bats. We found that narrowly distributed species are at a higher risk. 3% to 28% of assessed global bat caves needs urgent conservation intervention. So based on our data, it's safe to say that bats could be a useful surrogates for identifying and monitoring subterranean hotspots to protect other species. Our result from this work further highlight the importance of prioritizing bat caves at local scales, but show that broader scale analysis is still possible if robust cave data is present and effective parameters are included, for example, including an appropriate landscape features and threats. Lastly, developing priorities for these systems requires more systematic approaches, such as a standard measure to develop the priorities needed to maintain cave biodiversity. Developing science-based conservation priorities is crucially important to circumvent the threats of exceedingly high extinction rate for many species and ecosystems, and to effectively maintain biodiversity into the future. To To be effective conservation, it must be holistic and reflect species and ecosystem. On this work, we highlight the power of good data, integration, and the potential for impacts on policy. And we hope that with this work, we can begin to use a more data-driven approaches to help detect and better protect bats and their habitats. And that by working collaboratively, we can enhance our understanding of bats across the planet. Thank you so much, and I would like to thank everyone, including my institution, Chinese Academy of Sciences, the Dark Side S Project, and the National Research Council of the Philippines, and the University of Constance, and the University of Southern Mindanao in the Philippines. And I really want to thank the British Ecological Society for organizing this really fantastic and amazing conference. So once again, thank you so much, and I'm really happy to receive questions and inquiries regarding my work. Thank you so much.